today I want to talk about this problem, smallest sufficient team, problem 1125 in Leetcode. So start for people who are just starting Bitmask dynamic programming, it can be a little daunting. So I'm gonna try to explain even the most trivial operations that I perform for this for this problem. And yeah, I'll try to make it as easy as possible. And I'm planning to start a series on Bitmars DP. So this will be the first question in that series. So yeah, let's read the problem statement once. So in a project, you have a list of required skills and a list of people. The ith person contains a list of skills that the person has. So a sufficient team basically is one when you choose a certain people, when you choose certain people from this group. Like they should have all the skills needed as per this required skills list, right? So, and you want to choose the smallest possible team among these people. So, for example, in the first sample case, you have three people. The first person has a skill of Java, the second person has a skill of Node.js, and the third person has a skill of Node.js and React.js. So you can choose all three people, and that will give you all the required skills needed, right? But there's a smaller subset of this where you choose the first person and the last person, giving you all three skills needed. So that your aim is just that you have to choose the smallest subset of uh, this people list, which will satisfy all the required skills, right? So let's get into it. Yeah. So as I said, this is the required skills array, right? This is the people's array. Now, the first thing to notice for all bitmask problems, the most intuitive clue or the biggest clue for using bitmask dynamic programming is this constraint. So if it is anything less than 20, if it is something like 20, the constraint, the length is 20 or 24 or 16, this is a prime candidate for Bitmask DP, these kind of problems, right? So what is our idea here? We're gonna represent this required skills array as a bitmask. So what do I mean by this? So I start with no people in my team, right? So as per the question, when I start with no people in my team. There are three skills that are required. So what I'm gonna do is represent that bitmask by 000. So each skill has a position, right? So this is position 0, this is position 1, this is position 2. So now all three, and I'm going to read my bitmask from right to left. So if Java was in our skill set, it would be something like 001. If Java and Node.js were in our skill set, it would be something like 011. So this is what you're going to do. You're going to represent the set of skills you have at the beginning as uh, all zeros, right? So the mask or the bit mask in this case is 0. Now, what is your end goal? From this mask, you have to reach 111, right? So all three skills are present in your bit mask, right? Now, there's a very easy way to get this end mask. It's just one left shifted n times, where n is how many bits you require to represent this required skill array. So in this case, the maximum value could be 16, right? So you could have at the beginning 00000 16 times, and the end mask would be all ones. So from this, you have to reach this, or no matter what you do, right? So if n was suppose 4, you would have 4 bits to represent all the skills. And your end goal would be 111, right? So the first operation that you need to know about to get this value very easily is just you left shift 1 by n times, and then you subtract 1 to it. So for people just starting out, what does -1 do in a bit representation? Like if you have certain bits like this, what does -1 operation do? So it sets the last set bit, it inverts the last set bit to 0. So something like this, and every bit after that to 1. So this is a -1 operation in a bit mask, right? So when I left shift n, suppose n was 4, uh, I left shift n 4 times, 1 4 times, you'll get something like this, right? So at first you left shift 1 by 1 time, then second time, then third time, then fourth. You'd have something like this. When you subtract 1 from it, it inverts the first set bit, last set bit, and changes everything else to 1. So this is the first operation. So for this question, we now know our initial mask is 0, no matter how many bits are needed, and the end mask would be 1 left shifted by n times -1, right? So this is our goal. Now, what we'll do is, instead of dealing with strings here, as I said, I'll deal with positions, right? So Java would denote position 0. Node.js node would represent position 1. Then React as position 2, right? Now it just becomes a problem of dynamic programming where you either decide to take certain person or not take them. So for each position in people, you would have two options: take and not take. This is a very basic DP, right? Take or not take DP, and we have converted our solution into that form. So you have a bitmask starting mask, you have an ending bitmask, which is 1 left shifted n times -1. And for each position, you'd have two options: take this person or not take. If you take this, it's gonna change our bitmask in a certain way. If you don't take, we don't touch our bitmask because no skills have been added, right? So, and we're gonna be dealing with positions and not the strings, right? So we will have a map which will tell you what position each skill maps to. Okay, so now coming back to this part, this people part. Why this solution works for us, like this is first observation. This is sorry, this is the second observation. First one was because required length was low, you could have a bit mask. So for each state, you'd have either take or not, like if the skill has been taken or not. So you'd have two options for this, two options for this, so on. So 2 power n, right? So this in our recursive formula that we'll write, we'll at least pass a mask, right? And each mask will have 2 power n options, states. And as we said, for each people, we'll try to take or not take. So we also pass a position, right? Suppose this was of length m. So this would be something of a m into 2 power n solution after we memorize it. So let's talk about memorization later. We're just going to come to a recursive formula. Now the second observation is people length in our case is 60, less than 60, right? So what if we return a long value? Because long max is 2 power 63 minus 1, right? So think of it this way. This was our skill mask. Now the return value of our recursive function is also a mask, which is a long value. So what we mean by that, suppose there were 34, let's say 34 people with each varying skills. So our return value would have something like this. This is 34 bits. So what it would mean is uh, we chose this person, we chose the let's say 34, right? So 33rd bit is set, so we chose the 33rd person, we chose the 31st person. So this is our return value in this case. So when we have a return value as long, we'd have a set of bits, some set, some unset. So each set bit denotes a position in people and that we have chosen it. For zero, that means we did not take this person. Okay, so we have two or three things here with us. So first, our function will recurse over a mask and the position in the people array. So for each position, we take or don't take, right? So when we take all the skills in this person's skill set will get added to our original mask. So all skills in people pause get added to our current skill mask. In don't take scenario, we just increment pause by pause plus one. We do not change the mask. So for the next state after not taking would be just mask and pause plus one. And in this case, it'll be a new mask and pause plus one. Okay, so this is very simple. Now it all becomes a point of trying to implement it, right? So now what we'll do? Firstly, we'll take this people array, we'll iterate over this people array for uh, each list of string in people. We'll again create a mask. So let's say in this example, the third person has a skill of Node.js and React.js. Let's go with the third people two in zero index array. So they have a skill of Node and React.js. Now we already had a map which told you the position. So Java was 0, Node was 1, React was 2. So what we would do for each person, we'll create a people skill mask, which for this case should look like 110. Okay, so what I mean is they don't have the Java skill. It's missing for them. For the this is people two. For them, Java skill is missing. Node is there and React is there. For the first person who only had Java, so let's name it like this: people skill 0. Their skill mask was this. So Java was there, the Node and React weren't there. People skill 1, it's 010. So only Node was there. And for people skill 2, it's 110. So if you see, it's just each skill has been, whichever skill the person has, the people skill mask for that has been left shifted to that position. What do I mean by that? So for Java equal to zeros, Java was the 0th position skill. So what I did was one uh, left shifted 0 times. For Node was at position 1. So I left shifted 1 by 1. right? And in this third case, what I did was first I saw that node exists in their skill set. So first I left shifted one by one time, right? Then I ORed this with their second skill, React.js. So one left shifted two times. So this would give you this value, right? You can do this for the entire people array. And how many ever skills they have for each skill, you left shift one by the position of that skill and OR it with all the other skills in their skill set. So our whole for loop would look something like for I equal to 0, I less than people dot size and I plus plus or string, sorry, str in people dot get I, people skill mask I, odd with itself, one left shifted to whatever position the map contained for that string, get str, right? Why am I ORing this? Because they might have multiple skills and each position needs to be set for whatever skills they have. The positions of those need to be set. So you just OR it again and again. So this is our way of calculating people skill mask. Now, look at this. What we're gonna do in our recursive function is, suppose it's solve. We start off with a mask 0. That means no skills have been satisfied, which were there in skill set, and we are here at position 0, right? Now, let's talk about the base case. So, okay, we'll come back to the base case, but you know the base case is supposed to be if mask. So this was our mask, and this was our pause. If mask was equal to the end mask, which we discussed is calculated like this, you do something. If not, and if position has reached its end people's length, you do something. Now we come to the gist of the recursive function. What do we do here? So as I said, you either take something or don't take it, right? You either choose a person from people or you don't. Let's talk about what happens if you don't. It'll return not take. Let's call it not take. Okay, so in this case, your mask won't change because nothing gets added to the current skill set you have, which you're passing in this parameter of the recursive function. So if when you did not choose anything, the mask does not change, and you just call solve for mask and position plus one, right? Now let's talk about take. What happens then? So the as I said in one of the observations, the key idea here is the value that we are returning from this recursive function is going to be used to see which all people have been selected. And because people dot length was less than 60, I can return it as a long value, right? And that long value is going to represent how many, like which all indexes were chosen. So a long value will like something like 1001 would mean that I chose the person in position 0. Then I skipped the person in position 1. I skipped it in position 2. I chose 3 and 4. So the answer would be something like this. Sorry. 0, 3, and 4. Right? So this is why I'm choosing the return value to be long. So when I take the person, what happens? I left shift one by whatever position you're choosing. So as I talked about it here, this odd with solve of new mask and position plus one. So the idea here is because I chose the first person, I set its bit in a long value to one, denoting that I did choose this position. And then whatever gets returned from solve of new mask and position plus one. So this is going to return another long value with some other bits set, denoting I chose other positions as well. And combining them with or would mean, so I chose this person right now, and in future operations, I chose others. Now, what is this new mask? This new mask is nothing but mask odd with people skill mask. If you remember, we calculated the people skill mask here. So what did it do was for each person, what all it just showed you, which all skills did they have. So the new mask would be people skill mask at this position. Just because we chose them, it added certain new skills to our current mask, right? So I can rewrite this new mask to be this. And now the last part of the question is uh, which is the better option among two? So if you remember, the question asked you smallest sufficient size, right? Smallest size of the sufficient team. So there'll be multiple answers. So like in this example, if you choose all three, you'll get returned something like 111, right? But you only need the person at 0 and the person at position 3. So one left shifted by 0 times, which is this, and one left shifted by 2 times, which is this, set bit as 1. So 101. So you need this team rather than this one because it has fewer members, right? So our criteria in our case is just you choose a value which have lower set bits. So our option, let's say long option that we choose is the one with a lower set bit. So let's just call it bit for time being. Bit take less than number of set bits in not take. Then your answer is take. Otherwise, it's not take, right? And you return option. Now, going back to the base case. In when you have reached the mask, so what it meant was when mask represented the end mask, meaning all skills have been satisfied, right? All the skills that were needed and required skill have been satisfied, then you just return 0 in this case, right? Uh, to get the idea, when odd with 0, it would just mean you don't need anyone else and you can just like go ahead with previous odds of one left shifted pause times. But if this is not the case and you've reached the end, you return long max value. Why do you do that? Because long max value is nothing but 2 power 63 minus 1, meaning all 63 bits have been set. So when you go to choose the best option, you obviously won't take this option, right? Because this is the maximum number of people you can take, which will be always more than whatever the answer is. And required, the answer exists all the time. So when you return long max value, that means you reach the end of people, but mask hadn't been satisfied. So suppose there were 7 skills and something like this was the mask, right? So when you chose people in your previous recursive steps, you got all the skills except this one. But you reached the end of people, so that means there are no more skills to take, no more people to choose. So this skill will never be satisfied. In that case, it is not a possible answer. So you return long max value, uh, which won't be taken because it's not a better option. Yeah, so this is the whole solution. Now let's try to code it. Okay, so I'm going to call my length as n, right? And let's define our end mask. So this is our end. As I said, to calculate end in almost all the questions, if you're doing something like this, and this is like you need a end goal, mass should go from zero to something else. This something else is always one left shifted n times minus one. Again, next step, putting skills as per their positions. So I'll have a map of string and integer, right? So I go through the required skills array and I'll put each skills, like I'll equate each skill to a position. Now let M be the people size and I'll have a skill mask, right? This is the people skill mask, which is nothing but equal to the size of the bigger array. So for each person, you'll need a skill mask, and it can be satisfied in int because uh, like it's equal to the number of positions you would need for this n, right? So it's denoting how many skills out of these n skills does the person have. So this is to iterate over the people list, and for each string in their skill set. So as I said, now because each skill has been equated to a position, you can just left shift one by that string's position, that skill's position, right? And you OR it because for a person, you need to set all the bits uh, of those skills to one, right? Now, I'll call my recursive function now. So long team. So this is my chosen team. As I said, I'll recurse over two things. My initial mask, which is zero, so no skills have been satisfied till now, and you're at position zero in people. So now what does it look like? Private long, all int mask, and int pause, right? So let's come to the base case later. Uh, as I said, I have two options. Not take. In not take, our mask does not change because we did not add any new skills, but you move on to the next position. In the take scenario, what did I do? So as I said, return value for this function is such that each set bit denotes what position in people we have chosen, right? So if a bit in the return value is set, that means we have decided to include that person. What does that person mean? The position of that person in our team, right? So if I do choose to include this position, I'd left shift one long value position times, pause times to denote they have been chosen, and I'll OR it with the rest of the answer. Now, what is the new mask? The new mask is nothing but whatever mask we had earlier, ORed with people skill mask. Why did I do that? So that means I've added these people skill mask position to the previous mask, and it would have set some values to one in that original mask. And recurse for pos plus one. Now, as I said, uh, like each answer denotes how many people you've taken. So each person you've taken, their position has been set to 1 bit in our long answer. But you need the smallest sufficient team. So all you do is count the number of bits. You can actually do this manually, but long.bit count or integer.bit count is much quicker. So you check if long bit count take is greater than long bit count not take. If it is, then you take not take because you need lower number of bits set in your team, and otherwise it's take, and you return the answer. Yeah, so now you've done most of the work. All you need to do is from each position, you need to check how many people have been taken, which all people have been taken. So I'll initialize an array list, which will denote the position. So for int I0 to IM. So in this, what I'm going to do is I'll iterate through the people array once. And so this is the size of the people array. And just check if the position in the team is set or not set. If it is set, you include it in a result. So how would I go about doing that? I'll just check if team and one left shifted I times their position is not zero. That means that bit is set and you'd add it to the result, right? This is all you're doing. So as I said, the long value, the return value just denotes for each position if the person was chosen or not. So in this, you're just checking if the bit is set or not. So if it is, you add it to result. And in the end, you basically need an integer array denoting the position. So initialize answer of same size as res. So I is res dot get I. Yeah, so this is okay, skills length. Okay, I did not, sorry, this is a mistake. I did not write the base case. So if mask equal to end, so that means all the required skills have been met, like they have been chosen. In that case, you do not need to choose anything else. So you just return zero. Remember, we are going to OR it with whatever you get later on, right? So this is just saying you don't need to include anyone else. So you just return zero. But if position has reached the end of what people skill mask, so this is basically M. You return long max value, denoting all the bits are set. Like all, so max value is 2 power 63 minus 1. That means all 63 bits are set, right? And whatever your team is, it'll be less than that value. So this is never a good team. That means you were never able to satisfy all the required skills. So this was never going to be chosen as an answer. Yeah, I think this should work for smaller cases. Yeah. But now Why is this DP? Because it's going to TLE on higher end constraints. Yep. So now all I gotta do is just because mask could have 2 power n options and this could be m. So the whole solution is m into 2 power n, and I can use DP to do this. So I'm going to initialize long DP. Yeah, so I need it for mask and position. So mask could be at most end, right? So you just left shift 1 by n times, and then for position it's m. Actually for so this is just the end mask. Or what I'm doing is just filling the entire DP with -1. So this will be our another uh, this will be a caching. So if DP of mask and pause is not 1, -1, you return DP mask position. If not, you calculate it and then cache it for later on. I think it should work. Yeah. So that's it. Thank you.